Hey, good morning everybody. This is Mr. Ainsworth. We're going to get into drill 16 here and we're going to test some points and inequalities. But before we do, let's go ahead and graph one here and use it as our basis of which to understand our answers right here. So as we always do here, let's go ahead and isolate y to get in slope-intercept form. So let's do it on the right. We got 3x minus y is less than 2. Let's go ahead and add the opposite of 3 to both sides, or 3x, excuse me, which is a negative 3x. And I get negative y is less than negative 3x plus 2. Alright, I always do the additive inverse right there. Alright, I've got a negative y here, and I've got to handle that. So I'm going to divide everything by negative 1, which is going to switch the order of my inequality. So I have y is now greater than, switch the inequality right there, 3x minus 2, with a slope of 3 and the y-intercept of 2. So let's write down a slope of 3, which means up 3, right 1. Y-intercept is negative 2, or 0 and negative 2. This is called your y-intercept, and this is what you're going to be graphing here. We're going to analyze this first as we always do. I can see my inequality right here is greater than, so it's going to be dotted boundary line. Dotted boundary line, BL stands for boundary line. Alright, and it's greater than, so it's above. Okay, so let's go ahead and plot at negative 2 first. Keep your pencil there, go up 3, right 1, up 3, right 1, and there's your boundary line. Okay, use a pencil here because we're going to do some erasing here in a minute. Alright, there's your boundary line. We're going to make it dotted, so get your eraser out. Alright, and it's above because of the greater than. Okay, now, why are the solutions are above? Why are they? Well, let's go ahead and figure that out. One of the things we can do is you can test the origin. The origin here is in the region, right? So it's got to be a solution, but why? Well, let's see here. If I test 0, 0, just to check, alright, I've got 3 times 0 minus 0. Is that less than 2? Well, 0 minus 0 is 0, and 0 is less than 2. So, because that's a true statement, that tells me that 0, 0 is a solution. I just tested a point right there. And 0, 0 is right here. And it's in the yellow region, which means it's a solution. So I'm verifying my graph right here. I knew it was dotted and above, which tells me my solutions are above. Solutions are above. I know that. But why? Well, I could test a point to determine that. Alright, I just tested 0, 0, and I found it's a solution, which makes sense. They're not below the line, they're above the line. Okay, this is below. Alright, so now what we're going to do is we're going to test other points. Alright, my first point I want to test is 0, 3. I want to substitute it in. Alright, how do you do this? Well, you substitute your point into the inequality. That's all you do. Into the inequality. Alright, and see if it's a solution. So x is 0 and y is 3. Let's put them in. Let's see what happens. We've got 3 times 0 minus 3. Alright, is that less than 2? I don't know. We've got to check. Well, 0 minus 3 is negative 3. So the question is negative 3 less than 2? The negative 3 is to the left of 2, so of course it's true. Alright, so this tells me that 0, 3 is a solution. Why? Because this is true. Alright, whenever you get a true statement, that tells you a point that you're substituting is a solution. So state it. It's a solution, or is it not a solution? And if you look at 0, 3, it's right here in the graph. Alright, so y-intercept at 3, and it's in the yellow region. So of course it's a solution. So we can use the graph here to check. And that's what I was saying right here. Test each point in inequality above to see if it's a solution, and then check your graph to see if it makes sense. Well, 0, 3 is in the yellow area right here. Well, okay, so then it's got to be a solution. So let's do the other one here. I know that x is 2 and y is negative 3. So 3 times x, 2, minus a negative 3 here, because y is negative 3. Is that less than 2? I don't know. So let's find out. 6 plus 3. Got to add the opposite right here. Okay, add the opposite. Is that going to be less than 2? Let me see. 9 less than 2. This is obviously a false statement. Alright, 9 is not less than 2. Alright, so 2 comma negative 3 is not a solution. So it's pretty simple, my friends. All you do, if you test the inequality, if it's true, if it ends up in a true statement, all right, then it tells you that the point is a solution. If you end up with a false statement, the point's not a solution. And there are only two possibilities here, so it's not that hard. All right, so here we go. Let's substitute in a 0 here and a 2 here. So 3 times 0 minus 2, is that less than 2? Well, here I got 0 minus 2, which is negative 2. Is that less than 2? Well, of course, any negative is less than a positive, so this is a true statement. That tells me that my point, 0, 2, is a solution. Now let's go on the graph. Let's see if this is in the yellow area. All right, 0, 2. 0, 2 is right here. It's in the yellow area too, so it's a solution. The previous one, 2, negative 3, write 2 down, negative 3, is right here. That's 2, negative 3. And notice that it's not in the yellow area, so it's not a solution. Not a solution here, which makes sense because I tested it and it's not a solution either. Only points in the yellow region are solutions. All right, let's test 1, 4. Okay, so we got 3 times 1 minus 4. Is that less than 2? Well, 3 minus 4 is negative 1. Negative 1 is less than 2. This is a true statement, so obviously 1, 4, all right, is a solution. But let's see if it's in the yellow area above. Let's go 1 right, 4 up, see. So 1 right, 4 up, 1, 2, 3, 4. Here's 1, 4, right there. All right, 1, 4. It's on the graph. It's in the yellow area. All right, so it's making sense here. If it's in the yellow region, it's got to be a solution. All right, here's x is negative 1, y is negative 5. Let's see what happens here. So 3 times negative 1 minus a negative 5, is that less than 2? I don't know. So through negative 3 here, let's say I have the opposite here, plus 5. All right, is that less than 2? Well, I've got 2 here. 2 is not less than 2. 2 is equal to 2, obviously, and that tells me that negative 1, negative 5 is not, all right, a solution. If we go left 1 down 5, let's see if we're in the yellow area up here. So left 1 down 5, 1, 2, 1, 2, 3, 4, 5. It's on the boundary line. Negative 1, negative 5 is on the boundary line, and guess what? It's dotted, which means the solutions are not on the line. Okay. See, points that are on the boundary line that aren't solutions cause us to make dotted boundary lines. That's what it means. A dotted boundary line means the solutions are off the line. Dotted boundary line means the solutions, okay, are not, okay, on the line. They're above. That's what it means. If it's solid, it means the solutions are on the line. But if it's dotted, they're off the line. And that's why this point here is not a solution, because it's on the boundary line. Okay. If it was less than or equal to, well, it'd be a solution. We'd make that solid, but it's not. And the last one here, we got to check when x is 2 and y is negative 5, do we have a solution? So 3 times 2 minus a negative 5, is that less than 2? Well, here I got 6 plus 5. I have the opposite there, okay? Is that less than 2? Well, of course it isn't, because 11 is not less than 2. Okay, this is false, and that tells me that our point 2, negative 5 is not, okay, a solution. So let's see if it's in that yellow area up there or on the other side. Let's go left 2 down 5. So left 2 down, excuse me, not left 2, right 2, excuse me. That's a positive 2. So right 2 is over here, down 5. Ooh, you're right here. Okay, obviously that's not a yellow area, so 2, negative 5 is not a solution. All right, so you check the graph to see if it makes sense. If it's not in the yellow area, it's obviously not a solution. If it's in the yellow area, it's obviously a solution. All right, that's all there is to it here, guys. I use the graph up here to check your solutions to show you that it makes sense depending on what we get. Okay. And that's all there is to it. That's how you test inequalities. You just substitute in the inequality. If it's true, you have a solution. If it's false, you don't. There are only two opportunities here. And you just go with the flow. See you next drill.